All right, so um, you've sent over some really interesting material on numerical tool and process control programmers. So it sounds like you're ready to dive into the world of basically bringing machines to life with code.
Yeah, it's a fascinating field.
Yeah.
It really is a cool blend of digital and physical.
That's so cool.
Yeah, basically imagine taking something like a complex engineering blueprint.
Which already seems like a foreign language to most people.
Exactly. And then having to translate that into a language that a machine understands.
Oh, wow. So we're talking about programming languages here. Are we talking like the usual suspects, like your C++, Java, Python?
You'll definitely see those.
Yeah.
But then there's also something called PLC programming, which is very important in this field.
PLC programming, what is that?
PLC stands for Programmable Logic Controller. Think of it like this. A PLC is like a tiny, specialized computer that's built to control machinery. It's really the unsung hero behind the scenes, making sure everything runs smoothly. And just like any computer, it needs its own set of instructions, and that's where PLC programming comes in.
So is it like the conductor of an orchestra? But instead of musicians, it's coordinating motors and sensors and all sorts of industrial components.
Precisely. And just like a conductor needs to be fluent in musical notation, these programmers need to master PLC languages like ladder logic or structured text to tell those machines what to do.
It sounds like a very specialized field. I mean, it's not just about being good with computers. You need like a really deep understanding of how machines work on a physical level.
You hit the nail on the head. It really is fascinating. So, for
Yeah.
example, let's say a CNC machine, those computer-controlled tools that can carve out incredibly intricate parts, needs to create a complex curved surface for something like, say, a turbine blade.
Which are used in everything. I mean, we're talking about jet engines to power plants. Precision is key there.
Absolutely. And a numerical tool and process control programmer would take the blueprint for that blade with all of its curves and contours and write the code that instructs that CNC machine to cut it perfectly. We're talking about a level of accuracy down to fractions of a millimeter.
That's mind-blowing. Like digital sculpting, but instead of clay, you're shaping metal with lines of code. I bet debugging in this field is super intense.
Yeah, it definitely keeps you on your toes. One misplaced character in your code could mean the difference between a perfectly crafted turbine blade and a very expensive paperweight.
Oh my gosh, talk about pressure. So it's not just about writing code, it's about making sure that code is absolutely bulletproof.
Exactly. Troubleshooting and problem solving are a major part of the job. You need to be a little bit of a detective, figuring out why a machine isn't behaving as expected, and then diving into the code to find the culprit.
And I imagine with technology evolving so rapidly, it adds like a whole other layer of complexity to this whole thing.
Absolutely. The world of manufacturing is changing at warp speed with new technologies popping up all the time. And that brings us to a very crucial point about this career path.
So with technology changing so rapidly, what does that actually mean for someone going into this field? Like, are we talking about always having to learn new things and upskill?
You definitely have to be comfortable with being a lifelong student in this kind of role. You learn something once and you might be outdated in a couple of years, always adapting to new software, new programming languages, new machinery
Yeah.
is definitely a big part of it.
So that's something to keep in mind for sure. It sounds like it'd be appealing to some and like a total deal breaker for others. But let's say someone is up for the challenge. What does the career path actually look like? Where do you even begin?
Well, as with many specialized fields, having a really good educational foundation is key. So typically a bachelor's degree in computer science, electrical engineering, even mechanical engineering, that's a great starting point.
Makes sense. You need that programming know-how, but also that understanding of how things work mechanically.
Exactly. And while you're hitting the books, don't underestimate hands-on experience. So internships, co-op programs, even just personal projects, maybe you're into robotics or automation, those can give you a real competitive edge.
So don't just code in your basement, build something.
Exactly. Now, once you're actually out in the workforce, the learning continues, but you start to see a clear progression, like most jobs, in terms of responsibility and complexity as you move from entry level to senior positions.
So let's break that down a little bit. What might a recent grad expect in this first couple years as a numerical tool and process control programmer?
In those initial roles, you're usually working under more seasoned programmers. Think of it as your apprenticeship. You might be tasked with developing less complex programs, analyzing blueprints, running simulations, just to test and tweak things in a more controlled environment.
So kind of like learning your scales before you tackle like a Rachmaninoff concerto.
I like that. As you start to gain experience and confidence, you move into more junior positions where you have more autonomy. And this is really where those debugging skills become even more crucial.
Because things don't always go according to plan in the real world, especially when you're talking about complex machinery and code.
Precisely. 1 minute, everything's humming along. The next you have a line down because a sensor is sending faulty data. And it's up to you to figure out why.
It sounds like this job requires someone who really likes to solve puzzles under pressure sometimes with a tight deadline.
You got it. And if you really stick with it, you reach those senior level positions, which come with a whole new set of challenges and rewards.
Okay, so then at that point, are we talking about managing teams? Are we talking about even designing entire manufacturing processes from scratch?
All of that and more. You're leading teams, you're overseeing entire projects, you're mentoring more junior programmers. You might even collaborate with other engineers to develop completely new manufacturing processes. You become less of a programmer at that point and more of a visionary. You're the one looking at the big picture and seeing how automation can be used to solve problems and make everything more efficient.
That is so cool. But I do want to get a little bit more into like the practical side of things. A lot of people when they're looking at a career want to know like what can they expect to make? What's the earning potential?
It's a fair question. And the salary range can vary a bit depending on your experience level, location, the specific industry. But in general, you're looking at a median salary that's comfortably above the national average, even for those entry-level positions.
And then obviously that goes up as you gain experience and seniority.
For sure.
Yeah.
Senior-level programmers can earn a very comfortable living.
So we've got high demand, we've got specialized skills, we've got good earning potential. What's the catch?
Well, we've talked about the need for constant learning. You really have to be okay with that. Technology doesn't wait for anybody, especially in a field like automation, which is constantly evolving. So being comfortable, adapting, and always learning, that's important.
So almost like signing up for a lifetime of professional development, which again, some people might be like, yes, sign me up, and others are like, that's a hard no.
Exactly. And because this is such a specialized field, the job market can be a little,
Niche.
yeah, you might have to be open to relocating to find those really juicy opportunities.
Though remote work is becoming a lot more common now than it used to be, so that's maybe not as much of a barrier as it once was.
That's true, but it's definitely something to at least have on your radar.
So to recap, it sounds like being a numerical tool and process control programmer is challenging. It's demanding. It requires a very specific skill set that's constantly evolving. But it also has the potential to be at the forefront of really cool technology, and you can earn a good living. And so far, we've really only talked about, what it takes to become a numerical tool and process control programmer. But we haven't really touched on the impact it's having on the future of manufacturing as a whole.
Oh, it's huge. It really is. And it's only going to get bigger. I mean, we're already seeing how automation is transforming like every industry, and the role of these programmers is evolving right alongside it.
So what does that actually look like in the years to come? Are we talking about factories run entirely by robots with these programmers as like the masterminds behind the scenes?
Yeah, it's interesting to think about that because as automation gets more and more sophisticated, you can imagine these programmers being less about controlling individual machines and more about designing whole systems. Like, how do we optimize for efficiency and sustainability and even things like resilience to like disruptions?
So they're almost like architects in a way, but instead of buildings, they're designing the entire flow and function of like a modern factory.
Yeah, that's a great way to put it. They're bridging that gap between, the theoretical design and the real world production. And their expertise is becoming more and more valuable as all these industries are trying to figure out how to use technology to stay competitive.
It's fascinating stuff. We've covered so much ground from, the actual code itself, like that PLC programming, to, the future of manufacturing. For someone listening who's thinking, wow, this sounds really cool, where do they even begin to dive in a little deeper?
Well, there's some really great online resources out there. Industry forums and publications are good places to start to keep up on what's new. And nothing beats talking to people who are actually out there doing the work. Reach out on LinkedIn, go to industry events. The more you immerse yourself, the more it'll all start to click.
Yeah, there's nothing like connecting with people who are passionate and hearing about their work.
Absolutely. And it'll give you a much better sense of what it's actually like day to day.
Right.
The challenges, the rewards, the whole culture of the field.
For sure. Well, on that note, we'll leave you with one final thought-provoking question. We've talked about how automation is changing things, but what about how that reliance on automation will impact the demand for programmers going forward? Will it create more jobs? Will it change those jobs in ways we haven't even thought of yet?
It's a great question. And there's no easy answer. It's clear these programmers are vital to how things are made, but how that role will continue to evolve alongside the technology, that's a story that's still being written.
Such a good point. One thing is for sure, in the world of automation, the only constant is change. And to thrive in that kind of environment, you have to be adaptable. You got to be curious. You got to be ready to always learn something new.
Couldn't agree more.
A huge thank you to our expert for joining us and sharing these insights. And to you, our listener, thanks for sticking with us on this deep dive. We hope you've learned something new about the world of automation and the people who are out there literally coding the future of manufacturing. Until next time, keep exploring, keep learning, and as always, keep diving deep.